Okay, in this lesson, we're going to be talking about how to convert from standard form to slope-intercept form. So, a couple things to remember. First of all, standard form is ax plus by equals c. And then slope-intercept form is solved for y. So y equals mx plus b, where m is the slope and b is the y-intercept. So the first example that we're going to walk through together is converting 6x plus 9y equals negative 27 to slope-intercept form. One of the main reasons why we would want to do this is to make it easier to graph. Okay, so we are going to subtract 6x from both sides of the equation. We get 9y is equal to negative 6x minus 27. And we're going to divide both sides by 9. So we're going through the steps to isolate the y variable. So we get y is equal to negative 6 over 9x minus 27 over 9. Now, we can reduce that, so we always want to check to make sure that we do have reduced forms. So if we notice, 3 will divide in evenly into negative 6 and 9. So if we divide them both by 3, we would get negative 2/3 x. And then 9 does divide evenly into 27, and that goes 3 times. So our equation in slope-intercept form is y equals negative 2/3 x minus 3. Let's go ahead and graph that. So we're going to find negative 3 on the y-axis, since that's our y-intercept, and mark a point. And then we're going to use that slope of negative 2/3 to move to find our next point. So our rise is negative 2. So rather than going up, we're actually going to go down 2. And our run is positive 3. So we're going to move right 3. And again, mark a point. Now, notice that that is getting awfully close to the bottom of my graph. So instead of moving down and to the right, we could also move up and to the left. That would keep that negative slope, and the point still falls on the line. So let's go ahead and connect those 3 points to make our linear equation. Okay, the next example that we're going to walk through together says negative 2x minus 7y is equal to 9. And again, we want to convert that to slope-intercept form. So we're going to add 2x to both sides this time. And we would get negative 7y is equal to 2x plus 9. Then we're going to divide both sides of the equation by negative 7. And we get y equals negative 2/7 x minus 9/7. Okay, neither of those fractions can reduce any further, so that would be my equation in slope-intercept form. Okay, this next slide is a U-try. So we have 2 equations, both in standard form. Please convert those to slope-intercept form for me. Pause the video here and then unpause to get the results. Okay, here are those 2 equations, both in slope-intercept form. Number 1, we get y equals 3/5 x plus 2. Be careful, there was a lot of negative signs with that one that we had to take care of. And number 2, we have y equals 2/3 x plus 8/3. And that one had some fractions that we had to reduce. Okay, we also may have to convert from standard form into slope-intercept form when we have an inequality. So let's review these steps and how to graph an inequality as well. So with this first example, we're going to subtract 3x from both sides. We get negative 2y is greater than negative 3x plus 6. And we're going to divide both sides by negative 2. When we do this, be careful. Remember, when you divide or multiply by a negative number, we have to reverse the inequality symbol. So we get y is less than negative 3 divided by negative 2 would make positive 3 halves x, and 6 divided by negative 2 makes negative 3. Okay, let's go ahead and graph that. We have a y-intercept at negative 3. And we have a slope of 3 halves, so a rise of 3 and a run of 2. Now, when we graph inequalities, we do have to think about whether it should be a dotted or solid line. Since this one is just less than, it is going to be a dotted line. We do not want to include the points that are on the line. And for less than, we shade below the line. So we get a whole solution region with a bunch of different points that would be considered solutions to that inequality. Okay, this slide is a U-try. So again, we have two standard form inequalities. I would like you to convert those both to slope-intercept form, and let's practice graphing those as well. Pause the video here and then unpause to see the solutions. Okay, here's the results of the first one. When converting, I got y is less than 3x plus 4. I graphed that with a dashed line and shaded it below. And here's the results of number 2. When solving, we got y is greater than or equal to negative 1/2 x minus 9 halves. Plotting that, our y-intercept is negative 4.5. And then we went up 1 and left 2. Again, I could have moved down 1 and to the right 2, but notice that I'm off the graph. So instead I moved up and to the left. It's a solid line and it's shaded above. Okay, the last thing we're going to talk about today are word problems. So in this scenario, it says Sarah is planning a party. Sodas cost 50 cents per can and waters cost $1 per bottle. She has budgeted $20 for drinks. Write an equation that can be used to find, or to represent rather, the number of sodas X and the number of waters Y she could purchase. So let's go ahead and do that first. First of all, sodas cost 50 cents per can. So per, remember, is one of our keywords for multiplication. So we would take 50 cents, or 0.50, times the number of soda cans. So that's X. We would add on waters cost $1 per bottle. So plus 1 Y, number of waters are representing Y. Again, we really wouldn't need to write that 1 if we didn't want to, so we could just put 0.5x plus y. And if we spend all of the money, that would be equals 20. So that's our equation in standard form. We're asked to interpret the slope in the context of the question. So in order to know what the slope is, we need to convert to slope-intercept form. So let's go ahead and solve this equation for y. So we're going to subtract 0.5x from both sides. And we get 1y, or just y, is equal to negative 0.5x plus 20. We can see that our slope is negative 0.5. I'm going to go ahead and put this over 1. So 0.5 over 1. Remember, the 0.5 is telling me the rise, or The rise is how much is going up or down in the vertical direction, so change in y. And then the run is talking about how much is it changing from left to right, or the change in x. Let's go ahead and take a look at what those two variables are representing. Y is representing the number of waters. And we do have a negative. I forgot about that negative sign on there, guys. Sorry about that. So the number of waters is decreasing by a half for every one, and X is representing the number of sodas. So this basically means for every soda that I can purchase, I have to decrease the number of waters I can purchase by a half. Okay, the last slide in today's notes is another you try, and this is with a word problem. So go ahead and read through that scenario, pause the video, see if you can write an equation in standard form, convert it to slope-intercept form, and this time we're interpreting both the slope and the y-intercept. All right, pause the video here, and then unpause it when you're ready for those solutions. Okay, so here are our equations. In standard form, 9x plus 7y equals 63. And converting that to slope-intercept form, we get y equals negative 9/7 x plus 9. That slope is negative 9/7. If we convert that to a decimal, that's approximately negative 1.29. And I put that over 1. So that means that the number of cheese pizzas decrease by 1.29 for every additional veggie pizza that I buy. So obviously, the more veggie pizzas I buy, the less cheese pizzas I can buy. But this tells me exactly how many less. So negative 1.29 less cheese pizzas for every one additional veggie. And then our y-intercept is 9, and this tells me that I could buy 9 cheese pizzas if I don't buy any veggie pizzas. But the wife might not be very happy with that. All right, guys, this concludes the lesson for today.